Hello and welcome to 7.3, Product Sum Identities. So we have a couple of different things we're going to go through. First is double angle identities. The sine identities, sine of 2u is 2 sine u, cosine u. So notice it's 2 times u here, or just a u in the sine and cosine over here. So that's an identity we have to go from a double angle to the regular angle. That's why it's called double, because of the 2u. Now sine only has the one option, but cosine's got 3 options. Cosine 2u is cosine squared u minus sine squared u, or these next are derived by taking what we saw above and applying the trigonometric identities, or the Pythagorean identities, excuse me. Cosine 2u is 1 minus 2 sine squared u, and cosine 2u could be written as 2 cosine squared u minus 1. Use whatever's going to work best for you. So if it's got a bunch of sines in there, you might want to use this one, the 1 minus 2 sine squared u. If you have a bunch of cosines, all cosines, you might use this one. So tangent to u, there are 3 for this one as well. It's going to be 2 tangent u over 1 minus tangent squared u. This should be a tangent squared. There's a typo there. Or 2 cotangent u over cotangent squared u minus 1. Or 2 over cotangent u minus tangent u. Okay, so the first example here, we're going to determine cosine 2x, sine 2x, and tangent 2x if tangent of x is negative 4. So let me scroll up the screen here. So what we see here is that tangent of x equals negative 4, and we could write that as negative 4 over 1, because remember tangent is the opposite over the adjacent. So we could draw ourselves a triangle. Draw it like this, so we have this negative, and then here's the 1, and here's our x. We want us to find the other side, the hypotenuse of this right triangle. 1 squared plus negative 4 squared is equal to, we'll call that c squared. So 1 plus 16 equals c squared, so 17 is c squared, c equals the square root of 17. So then what is sine of x? Sine is going to be the opposite side over the hypotenuse, so negative 4 over the square root of 17. And cosine of x is going to be the adjacent side over the hypotenuse, which is 1 over the square root of 17. Now we're ready to find cosine 2x, sine 2x, and tangent 2x. For sine 2x, that's going to be 2 times sine x cosine x, or 2 times, and our sine was negative 4 over square root of 17, and cosine is 1 over the square root of 17. So that's going to be negative 8 over 17, because the square root of 17 times the square root of 17 is 17. For cosine 2x, we have the 3 choices. I think I'll use the one that is 2 cosine squared x minus 1. So that's going to be 2 times, and cosine was 1 over the square root of 17. We square that quantity, and we minus 1. So that will be 2 times 1 over 17 minus 1, or 2 17ths minus 17 17ths, which is negative 15 17ths. And for tangent 2x, I'll use the one that had just a tangent in it, so that's going to be 2 tangent x over 1 minus tangent squared x. And tangent was 4, so it's 2 times negative 4. Sorry, tangent's negative 4. Tangent x is negative 4. Over 1 minus negative 4 squared. Or negative 8 over 1 minus 16. Or negative 8 over negative 15. By the way, I could have just done sine 2x over cosine 2x to get tangent 2x. That's negative 8 over 17 over negative 15 over 17, which would have been negative 8 over negative 15. What we have here, which is 8/15. So that was using these formulas to find sine, cosine, and tangent of 2x, given that we know one of them. So the next problem we're going to do, we're going to evaluate or verify the trigonometric identity. So I need to scroll up and erase the board, so feel free to pause here. What we have is sine 3x over sine x equals 3 minus 4 sine squared x. I'm going to work on the sine 3x over sine x, trying to make this side look like that side. So first of all, let's consider sine 3x. Sine 3x is like saying sine of 2x plus x. 2x plus x is 3x, so sine 3x. Now I use my sum identity. That's going to be sine 2x cosine x plus cosine 2x sine x. And now we know what sine 2x is. Let's bring that down to become a sine. So this is going to become 2 sine x cosine x times cosine x plus, and then cosine. We have some choices. I'm going to go with cosine squared x minus sine squared x, the first one, times sine x. We could try different ones. I'm going to go with this one. Excuse me. This is going to be 2 times sine x cosine squared x plus cosine squared x times sine x minus sine squared x times sine x. So we have what? 2 sine x cosine squared x plus cosine squared x sine x. This makes 3 sine x cosine squared x minus sine cubed x. And just remember, this was all just what sine of 3x is. So we look at sine 3x divided by sine x. We have 3 times sine x cosine squared x minus sine cubed x all over sine x. So if I divide a sine x out of the numerator, I get what? 3 cosine squared x minus sine x, sine squared x. Now what is cosine? Cosine is 1 minus sine squared x. Cosine squared is 1 minus sine squared x. If I distribute 3 minus 3 sine squared x minus sine squared x, that's 3 minus 4 sine squared x. And that's what we wanted. That was our goal. Now I tend to wonder, what if I tried, instead of doing cosine squared x minus sine squared x, if I did 1 minus 2 sine squared x? That may have been another choice we could have pursued. Had it all in terms of sines. But there we go. Okay, feel free to pause there. The next part we're going to discuss are power reducing identities. So to go from being squared to being linear. So sine squared x can be reduced to be 1 minus cosine 2x over 2. Cosine squared x is 1 plus cosine 2x over 2. So notice how these are similar. Sine has the minus, cosine has the plus. And then tangent is just like taking sine squared over cosine squared. That's tangent squared. That's the 1 minus cosine 2x, see that? Over 1 plus cosine 2x. So we're going to rewrite sine the fourth power of x in terms of containing only first powers of cosine. So let me scroll up the board. This is a problem I tend to put on exams, something like this. And some people, you always get those students who don't want to go all the way through with it. First, I need to have you recall that a minus b squared equals a squared minus 2ab plus b squared, and a plus b squared is a squared plus 2ab plus b squared. So what's important is to remember these relationships, because a lot of people are still forgetting, and they make mistakes they would have made back like in 095. They're beginning algebra, they forget the middle stuff. That's going to be a problem. So first consider sine to the fourth power x is sine squared x times sine squared x. And sine squared x is 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. Now we have this 2 down here and the 2 down there. We could pull those out. That just makes 1/4 times what? I have 1 minus cosine 2x times 1 minus cosine 2x. That's 1 squared is 1 minus 2 times 1 times cosine 2x plus cosine squared 2x. So if we distribute that 1/4, we have 1/4 minus 2/4 cosine 2x plus cosine squared 2x over 4. And the deal is we now have a cosine squared, and we're supposed to have all linear terms for cosine. So this one has to be reduced now. The others are fine. This one has to be reduced. So we get our 1/4 minus 1/2 cosine 2x plus 1/4 times, and this reduction is 1 plus cosine of 2 times 2x. See, it's 2 times whatever's inside here. Where am I here? 2 times whatever's inside there. All over 2. So we have 1/4 minus 1/2 cosine 2x plus 1/4 times, we have 1/2 plus cosine 4x over 2. So I'm not quite finished. I want to clean it up a little bit. This is 1/4 minus 1/2 cosine 2x plus 1/8 plus cosine 4x over 8. This whole thing over 8. We can combine the 1/4 and the 1/8. 1/4 plus 1/8 is 3/8. 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. And there's our final answer. These cosines cannot be combined because that's a cosine 4x. This is a cosine 2x. Okay, feel free to pause that. Here, next part, we're going to talk about half angle identities. Sine of x over 2, and remember we had double angle before, this is half angle. Sine of x over 2 is plus or minus 1 minus cosine x, square root of 1 minus cosine x over 2. Okay. Notice this is x, where we had x over 2 out here. Cosine of x over 2 is plus or minus 1 plus cosine x over 2. So notice the negative up there, the positive down here. Tangent of x over 2 is plus or minus 1 minus cosine of x over 1 plus cosine of x, which is what we see, cosine, sine over cosine. Or, this is kind of cool, sine of x over 1 plus cosine of x, or 1 minus cosine x over sine x. Now what's important is to remember these plus and minuses. It says plus or minus because the square root is going to produce a positive. But depending on the quadrant you're in, and you'll know that by x over 2, if sine's positive, where x over 2 is, if that's going to be positive, you make it positive. If it's negative, you make it negative. Same thing here for the cosine and the tangent. You have to look at this part here. Where is x over 2 falling to know if you should do the positive or the negative? So the first one we'll look at is tangent of 7 pi over 12. Now 7 pi over 12 is not a standard value for us, excuse me, but tangent of 7 pi over 6 over 2, 7 pi over 6 is standard. That's a standard value. So we can look at this as being, now we don't have to worry about the plus or minus if I don't use the radical. Sine of 7 pi over 6 over 1 plus cosine of 7 pi over 6. Sine of 7 pi over 6, that's negative 1/2. And cosine of 7 pi over 6 is negative square root of 3 over 2. So we have negative 1/2 over 2 halves, 1 is 2 halves, minus the square root of 3 over 2. So negative 1/2 over 2 minus the square root of 3 over 2. We have as a fraction divided by a fraction, so negative 1/2 divided by 2 minus the square root of 3 over 2 is negative 1/2 times 2 over 2 minus the square root of 3. Twos divide out. We have negative 1 over 2 minus the square root of 3. And that is the answer, but we're not supposed to typically leave our answers with radicals in the denominator. So I'll multiply by 2 plus the square root of 3 over 2 plus the square root of 3. We end up with negative 2 minus the square root of 3 on top because it's negative 1. Then we end up with, because this is a FOIL situation, a minus b times a plus b, 2 squared minus square root of 3 squared. So we end up with 4 minus 3, which is 1. So our final answer is negative 2 minus the square root of 3. And if you look at my notes online, the answer is negative square root of 3 minus 2. It's the same answer. Okay. As usual, feel free to pause that. I'm going to scroll up. Give myself more working space for the next problem. Cosine of 165. This again is not one of those standard values, so we got to find, could this be a half angle? I mean, we could write this as cosine of 330 degrees over 2, because 330 divided by 2 is 165. 330 is a standard one, so we'll do cosine of 330. Now, I'm not talking about cosine of 330, I'm talking about cosine 165 is what we're trying to find. That is second quadrant. Cosine's negative there. Okay, so that means our answer is going to be negative square root of 1 plus cosine 330 degrees over 2. One plus, now cosine 330 is square root of 3 over 2, all over 2. We have the negative square root of 2 halves plus square root of 3 over 2. This is going to be a common procedure here to combine the numerator. Negative square root of 2 plus the square root of 3 over 2 over 2. That's like saying the negative of the square root of 2 plus the square root of 3 over 2 times 1/2. If you need help seeing that, think of 2 plus the square root of 3 over 2 divided by 2 is 2 plus the square root of 3 over 2 times 1/2, multiplied by the reciprocal. So we have the negative of the square root of 2 plus the square root of 3 over 4. And we could stop there, but we could simplify this a little bit. That's the negative square root of 2 plus the square root of 3 over the square root of 4, or the negative square root of 2 plus the square root of 3 over 2. That's it. Okay, feel free to pause. Our next part is product to sum identities. Product to sum. If you have a product of two things, you can make it into a sum. And then we'll see some of the product identities in the next part. So sine x cosine y equals 1/2 of sine of x plus y plus sine of x minus y, where x was the angle inside sine, y was the angle inside cosine. Sine of x times sine of y is 1/2 cosine of x minus y plus cosine of x plus y. Cosine of x sine of y is 1/2 sine of x plus y minus sine of x minus y. Looks a lot like the sine x cosine y. The difference is there's a negative here. And cosine x cosine y is 1/2 cosine of x plus y plus cosine of x minus y. So I have an extra parenthesis in these. Okay, use the product to sum identities to rewrite the expression as a sum or a difference. Okay, so we're looking at 1/2, always have a 1/2 out front, times, it was sine of pi over 4 plus pi over 4 from here, minus sine of pi over 4 minus pi over 4. That's 1/2 times sine of pi over 2 minus sine of 0. So 1/2 times 1 minus 0, which is 1/2. Now we could have worked it out the other way, just to check. Cosine of pi over 4 times sine of pi over 4. That's square root of 2 over 2 from the cosine. That's square root of 2 over 2 from the sine. That's 2 over 4, which is 1/2. So it works. And now we'll look at the second part. Sine of 5 pi over 6 times cosine of pi over 6. That's going to be 1/2 times sine of 5 pi over 6 plus pi over 6 plus sine of 5 pi over 6 minus pi over 6. 1/2 times sine of 6 pi over 6 plus sine of 4 pi over 6. 1/2 sine of pi plus sine of 2 pi over 3. That's going to be 1/2 times 0. Sine of pi is 0. Sine of 2 pi over 3 is the square root of 3 over 2. So that's the square root of 3 over 4. Okay, feel free to pause. Our last topic of this section, as I previously stated, is sum to product identities. We did product to sum, now sum to product. Okay, sine of x plus sine of y equals 2 times sine of x plus y over 2 times cosine of x minus y over 2. Sine of x minus sine of y is 2 cosine of x plus y over 2 sine of x minus y over 2. Cosine of x plus cosine y is 2 cosine of x plus y over 2 cosine of x minus y over 2. And cosine of x minus cosine of y is negative 2 sine of x plus y over 2 sine of x minus y over 2. So we have sine of pi over 4 plus sine 3 pi over 4. We'll use the first one. That's going to be 2 times sine of pi over 4 plus 3 pi over 4 over 2 times cosine of pi over 4 minus 3 pi over 4 over 2. That's 2 times sine of pi over 2, because pi over 4 plus 3 pi over 4 is pi, the 2's down there, times cosine pi over 4 minus 3 pi over 4 is negative 2 pi over 4 over 2. That's 2 times sine pi over 2 times cosine of negative pi over 2 over 4. Over 2, excuse me. So it's 2 sine of pi over 2 cosine of negative pi over 4. Well, sine of pi over 2 is just 1. Cosine of negative pi over 4 is square root of 2 over 2. So the 2's divide out. And we have the square root of 2. Now in the second case, we have more of a general case because we have x in there. So it's it's negative 2, so I'm doing cosine minus cosine, so it's negative 2 sine of the sum of these two angles, 6x plus 2x divided by 2, times sine of the difference, 6x minus 2x over 2. So it's negative 2 times sine of 8x over 2 times sine of 4x over 2. Negative 2 sine of 4x, sine of 2x. And that'll do it for this section. Thank you, and send me your questions.